Welcome to Lavanya's computer classes. In this video, I will explain spanning tree. After that, I will explain the next video, minimum spanning tree. First, I will go for what is a spanning tree. What is a spanning tree means, first I will take some example. This is a graph. 1, 2, 3, 4, 5, 6. This is a graph. So, what is a graph first? Graph is represented with the letter G. G equal to V comma E. That means number of vertices comma number of edges. So, in this example, what are the vertices? V means vertex set, that is called as vertices. E for edge set, number of edges. So, in this example, how many vertices are there? Means 6 vertices are there. Those are 1, 2, 3, 4, 5, 6. Vertices are represented with circles. 6 vertices are there and edge. What is edge? Means connection between one vertex to another. 1, 2, 2. 1 comma 2 is one edge. 1 comma 3. 2 comma 4. 3 comma 5. Then 4 comma 6. 5 comma 6. These are the edges. Connection between one vertex to another vertex. So these are the edges. So how many edges are there? Totally 6 edges are there. So this is a simple example for a graph. For this graph, now I will go for spanning tree. So what is a spanning tree means? Spanning tree is a subgraph of a graph. Spanning tree is a subgraph of a graph. That means it is also a part of a graph with same vertices and edges. But how many vertices, how many edges of this subgraph means vertices are same number. In the original graph, how many vertices are there? Same number of vertices are there for spanning tree also, but not same edges. We have to remove some edges, less edges only. So how many edges we require, I will explain in this video. So in the above example, how many vertices are there? 6 vertices are there. So in the spanning tree also, we have 6 vertices. I will draw on some another paper. So in the spanning tree also, how many vertices we need? 6 vertices with the same position. Don't change the structure of the graph. Original graph, how it will be? Same like that we write in subgraph also. So 6 vertices with the same positions. We write all are in the same places. Now we need, so vertices are same, that is V is 6, but edges how many? Less edges. So how many edges means simple thing is V minus 1. That means how many vertices are there in the original graph? 6. 6 minus 1, 5. So in this spanning tree, how many vertices we require means same number of vertices in the original graph. How many edges we require means vertex minus 1, that is 6 minus 1, 5. So in the spanning tree we need vertices are 5, 6 edges also 5. And one more method for finding how many edges we require means m minus n minus 1 formula. What is m means number of edges, n is number of vertices. So how many edges are there in the original graph? 6 edges are there. So 6 minus, how many vertices are there? That is also 6. 6 minus 1. So 6 minus 5, that is 1. What is this 1 means? One edge we have to remove, that number of edges. One edges we have to remove from your original edge. So in the original edges, how many edges are there? We have 6 edges are there. In the 6 edges, how many have to remove? 1, according to m minus n minus 1 formula. So in the subgraph, how many vertices we need mean that is 6. How many edges we need means already 6 is there. We have to remove 1. So that is 5. So 5 edges we have to draw on the spanning tree. So here 6 edges are there, but in the spanning tree, any 5 edges. So 1, 2, 3, 4, 5. So this is the spanning tree of your original graph. Vertices are same, but edges we have to remove only. We have to keep only V minus 1. So like that we can draw any number of spanning trees. Now I will show you some possible spanning trees of your original graph. So number of vertices are 6 within the same positions. But how many edges we need? Just we need only 5 edges. Vertices are 6, edges are 5. So any 5. 1, 2, 3, 4, 5. So this is the spanning tree of original graph. And one more. Vertices are same, within the same places. But how many edges we need? Only 5. Any 5. So 1, 2, 3, 4, 5. So this is one more spanning tree. And one more spanning tree. Like this we can draw any number. So again same vertices with the same positions. But we have to select any 5. So 1, 2, 3, 4. One more wherever you want to. So this is 5. So these all are the possible spanning trees from your original graph. Like this we can draw any number. So how many have to write? What is the possible spanning trees we have to draw? And for that we have one formula is there. That is mod E C mod V minus 1. Vertices minus 1 minus number of cycles. If the original graph contains any cycles, cycle means loop. How many cycles are there? We have to remove all the cycles. So this is the formula for finding number of spanning trees, possible spanning trees from your original graph. Thank you for watching my video. If you like this video, please subscribe my channel, share it to your friends. Thank you.